Question 1, x squared plus xy equals 10. So when x is 2, what is dy dx? So first we have to find dy dx by taking a derivative of each individual piece of this curve. So we get the derivative of x squared is 2x plus. Now this derivative is a little bit trickier. It's x times y, so it's a product. So we have to do the product rule. So we do the derivative of the first function times the second function. So derivative of x is 1 times y plus, now we're going to do the first function times the derivative of the second function. So we do x times dy dx is the derivative of y, and that's equal to 0. So now we are going to isolate dy dx. So we get x dy dx equals negative 2x minus y. So then dy dx equals negative 2x minus y over x. So if you notice, the problem says that x is 2 and we want to find dy dx. So that gives us negative 2 times 2 minus y over 2. Oh man, we need to know what y is, but we have a curve that gives us an xy relationship. So if we get 4 plus 2y equals 10 by plugging in x equals 2, then we get 2y equals 6 by subtracting 4 over, and then we get y equals 3. So now we can come down and we can plug in that. So we get negative 4 minus 3 over 2, which is negative 7 halves. So that is answer A. Okay, number 2, f of x is sine of e to the negative x. So we have the function e to the negative x plugged into sine, and negative x is plugged into e to the x. So we basically have a double chain rule happening here. So the chain rule says, do the derivative of the outside function first, so that's sine. So we'll do cosine. Inside stays the same. And then now we have to multiply by the derivative of the inside function. Well, the derivative of e to the negative x, well, that's going to be e to the negative x. But then now we have to multiply by the derivative of negative x, which is just negative 1. So overall, that's going to give us negative e to the negative x times cosine e to the negative x if we do a little rearranging. So it looks like that is answer E. For number 3, we have a product of x times sine x, and we're trying to find the derivative, so this is going to be the product rule for derivatives. So the derivative of the first function is 1 times the second function plus the first function times the derivative of the second function, which is cosine x. So we have sine x plus x cosine x, and that is answer B. So again, product rule says do the derivative of the first function, multiply it by the second function, plus the first function multiplied by the derivative of the second function. Definitely going to want to remember that. Number 4 is asking us for f prime pi over 9. So before we can plug in pi over 9, we must find f prime. So we have f as cosine 3x. So again, this is going to be a chain rule. The derivative of the outside function is negative sine. Leave the inside function alone, then multiply by the derivative of the inside function, which is 3. So we get negative 3 sine 3x. So now we're going to plug in pi over 9 to that, negative 3 sine. 3 times pi over 9 is 3 pi over 9, which ends up being pi over 3. That's how it simplifies. So we're doing negative 3 sine pi over 3. Sine of pi over 3 is root 3 over 2, so we get negative 3 root 3 over 2, and that is answer E. Okay, for number 5, we have y equals x cubed minus cosine x, all raised to the 5th. So again, this is a chain rule, and just to talk about the chain rule a little more carefully here, we basically have two functions here. We have parentheses to the 5th, and we have x cubed minus cosine x. So what the chain rule says, if you take a function and plug it into another function, you have to. That's what makes us apply the chain rule of derivatives. So the derivative of parentheses to the 5th is always going to end up being 5 parentheses to the 4th, and the rest of the derivative depends on what's inside here. So in this case, we're going to do 5 x cubed minus cosine x to the fourth, and then multiply by the derivative of x cubed minus cosine x, which is 3x squared. Derivative of cosine's negative sign, so this is going to simplify to positive sign with that negative there. Okay, so when we do y prime, we're going to do 5, leave the inside alone, to the fourth. So that's just our power rule. And then we multiply that by the derivative of the inside function, which is 3x squared plus sine x. I know I'm bleeding over into this other work here. Okay, but that's our final derivative there. And that looks like answer E.